Using a suitable solvent technique, basically this depends upon, we can take suitable solvent, the one which can dissolve only one of the components from the mixture. For example, if we talk about sugar, if we have a one solid mixture of sugar and salt, so if we have to separate sugar and salt from each other, we need a solvent which can dissolve only one of them. For example, if I put that mixture in the water, what will happen? Water can dissolve both salt as well as sugar, right? Both are soluble in water. So that then see the water is not a suitable one because it is dissolving both the things. So I am not able to separate anyone. So, but if I take ethanol in that case, ethanol is the organic solvent which dissolves sugar only and cannot dissolve salt. So when I add that mixture in the ethanol, ethanol will dissolve all the sugar from it. Salt remains as insoluble. I will do the filtration. Will get the salt as a residue. Then crystallize the filtrate. So I will get the sugar separately. So see, that's how it gets separated. So ethanol is the suitable solvent over there. In the same way, for example, if I have a mixture of a salt and sand, so now here water will be the suitable solvent because water can dissolve salt in it and sand is not soluble in water. In the same way, when we talk about copper and copper oxide, copper, if you recall the reactivity, copper is below hydrogen in the reactivity series, which means that copper metal is very less reactive and would not able to react with the water, will not react with the acid as well. But copper oxide, its metal oxide reacts with the acid. So if I have to separate the mixture of these two, I can easily take HCl because HCl will be the suitable solvent. It can dissolve copper oxide in it and cannot dissolve copper metal. So the suitable solvent is always the one which dissolves any one of the solid component of the mixture. Is this clear? So this is the method how we will do the separation from the by using the suitable solvent method. These are the 4 steps. Note these down quickly, then we will proceed further. Yes, Khatija, is this clear to you as well?
Yes, sir.
Okay, great. Completed quickly. filtration with copper side from lemons. Filtration with copper. Yeah, filter is the residue and copper oxide is in the filtrate, so we'll crystallize it to get the solid copper oxide from the filtrate solution. Is everybody done?
Yes, sir.
Okay. Now we have another process called distillation and fractional distillation. Okay. Method. Okay. So difference between distillation and fractional distillation. Both occur in the same way, but there is only a difference that when we do distillation and when we do fractional distillation is, for example, if I have a salt solution, right? Okay, just tell me if you have a salt solution and you need to obtain a crystals of salt, what you will do? Crystallization, because we need a pure solid, right? But if I need a water from the salt solution, pure water, what I will do? Distillation. Because in evaporation, all the water gets evaporated, right? How you will get it? So we'll do the distillation. But now, if there are two or more liquids which are mixed together and I have to separate those mixed liquids, then I will do fractional distillation. So distillation is done when we have a solution of a solid and a liquid, and we need a pure liquid, we will do distillation. And we have a two or more mixture of two and more than two liquids, then we will do fractional distillation. Is this understandable to all of you? Yes, Khatija, did you understand?
Yes, sir.
Clear? Okay, note this down. Second point liquid air. Actually, air is a mixture of gases. So being as a gas, we cannot separate them. So we will cool that mixture of gases so all the air becomes liquid. And then we will do the fractional distillation of that liquid air to separate nitrogen, oxygen, and the rest of the gas. So can you please explain this again? Which thing? Air is a mixture of gases. So we cannot separate the gases from the air until we make it liquid. So we cool the air to make it liquid air. And then from when we have a liquid air, we will do the fractional distillation of the liquid air to separate the gases in the pure form, to separate nitrogen, oxygen, and every other gas. Is this clear to all of you? Okay. So, okay, first do this quickly, then I will explain both the processes. Crude oil have petrol, diesel, kerosene, jet oil, lubricating oil, naphtha, paraffin. There are so many liquids. Okay. And take note down criteria. Okay. If you look at the set of apparatuses on both sides, they are almost the same. Let me zoom in so you will identify the difference. If you see over here and over there, what is the difference in both of them?
The difference is of fractionating column.
There's only a difference of this thing. In fractional distillation, we add this one extra apparatus which is called fractionating column, and that is not over here. Okay. Now let's understand how the distillation will separate and help us to get the pure water. Here, this is the container where we put the solution from which we need the pure solvent. This is the container where we get the pure solvent. This apparatus is called condenser. Okay. If you look at condenser more closely, you will find that there are two parts basically. One is a very narrow pipe in the middle, and there is another broader pipe or a broader tube. So these two are separated with each other. If you see from in the broader or the outer pipe or outer tube, there is a movement. This is how water moves. We actually provide a continuous supply of a cold water from here, and that water fills up this whole tube and then start leaving from there. So continuously cold water is entering that outer tube from here and moving out from there. What will it happen? It will cools the wall of this inner tube. Okay, it will cools the wall of this inner tube. Okay, what we will do? We will want a pure water from the salt water. We heat it. On heating, all the water evaporates. When it evaporates, it reaches over here. It get only this space to move. So when this all water vapors move over here, so see what will happen. These water vapors are moving in this direction, and they are very hot. And the cold water is continuously moving in this direction, right? So what will happen? That these water vapors losing the energy to the water molecules, and the water molecules getting hotter and going outside, and continuously a cold water coming in. So as a result, what will happen? Whatever the vapors which reaches in this region condenses and turns into liquid again. And as a liquid, they start collecting over here. So that's how distillation helps us to get the pure water from the solution. Is this understandable? So cold water is mixing. How it is moving in the outer tube, and in the inner tube there is a water vapors. So how they will both mix? Boundary and cold. Yeah, the cold water is in the outer tube. Steam or the vapors are in this inner tube. So both stay separated. Yes, is this clear to all of you? Okay.
सर कंडेंसर वाला दोबारा बता दें.
As the vapors reaches over here, and the cold water is moving in this way, which is actually keeping the whole this inner tube cold. So due to that, what happens that the water vapors continuously loses the energy, and finally they condense it and turns into liquid. And as they turns into liquid, we are going to get a cold water over here collected. Now have a look over here in the fraction in this. What is the difference over here? Okay, when there are two liquids, right? Here we have two liquids. Now think water evaporates at 100 degrees Celsius, but do water boils at 100 degrees Celsius, but do water turns into gas before 100, below 100? No. Or yes? What will happen if water over here? It also turns into liquid, into gas by evaporation, right? So it means if we have a mixture of liquids over here, and when we heat it, what will happen? That all the liquids get evaporated, all the liquid molecules will be evaporated, right? So how then separation will occur? So that for that purpose we put the fractionating column over here. What will happen? For example, let's suppose here in this solution there is a ethanol and there is a water. The melting point of ethanol is 78, sorry, the boiling point of ethanol is 78 degrees Celsius and the boiling point of water is 100 degrees Celsius. Right now, we didn't start heating, so the temperature is 25 degrees Celsius. So when we start to heat, as the temperature rises, what will happen? Water evaporates, ethanol evaporates, both reaches over here. But what will happen? That both, as you see, there are so many barriers over here, which increases the surface area. So the vapors which comes over here does not directly move over there. They start colliding and losing the energy in this region. And as a result, they again condenses and falls back over there. And this same thing happens until the boiling point of one of the liquid reaches. Until the boiling point of, if the boiling point of none of the liquid is reached, then no molecules which are evaporated from here escape this fractionating column. They always condenses in the middle anywhere and then falls back. Okay, is this so that is what fractionating column do. So now think, after some time the temperature is raised to 78. When the temperature is now raised to 78, it means now ethanol will boil only and water still evaporates. So what will happen? The ethanol molecules now, as its boiling point is reaches, so it is not able to convert into liquid and it escapes the whole fractionating column and reaches to the condenser. But the water vapors, because the boiling point of water is not reached yet, so the water vapors condenses in the fractionating column and then falls back. So that is how fractionating column helps us to separate both the or more than both the liquids. Okay, so if the boiling is taking place, is the temperature increases or remains the same? It remains the same until the whole boiling is taking place. So we got a constant temperature over here until all the ethanol is collected. So once all the ethanol is moved from this container and collected over here, we will see a rise in temperature. And that rise will indicate us that all the ethanol is collected. So we will remove this container and put another container for water or for any other liquid. Is this the rise of, for example, when the temperature reaches to 78, we know there is a ethanol. So all the ethanol starts boiling now because its boiling point is there. And it starts collecting over here. See? So the temperature remains at 78 until all the ethanol has been removed from here. So once all the ethanol is collected, now temperature does not remain constant, it starts to rise a little. So as soon as it starts to rise, it indicates that all of the ethanol is collected. Now we will remove this container and put the another container. So when the boiling point of the other liquid reaches, then that liquid starts collecting in the new container. Is this understandable? Yes. Yes, Manali. Yes, Khatija and Abdul Sami. So this is the reason for fractionating column. Okay, I'll suggest you, if you guys take the picture of these two. Let me zoom in its distillation.
Sir,
Yeah, I'll share the PDF as well. I think I have shared it or not. This whole file is shared. Okay. This whole file is in the group. You are added in the group.
फ्रैक्शनल डिस्टिलेशन में भी कंडेंसर लगा हुआ है.
Yeah, there is one more apparatus which is fractionating column over there. So it helps to separate the vapors of the liquids in the fractionating column. And there is always a movement of water in the opposite direction as the movement of vapors, which will make the vapors move become gets cooled more quickly and turns into liquid. Okay. So see, that's what I have discussed earlier. Salt and water have a different boiling point. So if there is a salt solution and we need to separate salt from it, what we will do? We will do crystallization. But from the salt solution, if we need to separate up pure water, then we will do simple distillation. And this is the process. Okay. Complete this.
Sir,
Yes.
sir, I want to ask कि जो fractionating column के अंदर क्या process होगा जब तक वो boiling point reach नहीं होगा? Can you please explain it once again?
Actually, there are so many particles, sometimes glass beads are over there. That is not a clear path for the vapors. So when vapors start colliding with those particles, they lose energy. And they doesn't have enough energy to stay as a gas because their boiling point is not maintained. They are at a lower boiling point. So by colliding with the walls or with those glass beads or with those barriers, it will lose so much energy that it turns into liquid and then falls back. That's what happened in the fractionating column.
Okay, sir.
Is it clear or not?
वो ऊपर वाला features लिखना है।
Clear, sir.
Third, we have to do separate only when solvent we use distillation. If there are medical solvent, we use fractionating distillation.
Fractional distillation. Last one. Liquid solid. Something. This time. पिछली क्लास में हमने क्या टाइम बताया तुम को 3 to 4 Is everybody done? Yes, Rohan?
Yes, sir.
Okay. Yes, Rohan. In sort of review. The most common application of fractional distillation is in hydrocarbons, where we get the crude oil, which is a mixture of so many liquids. So we will separate them with the help of fractional distillation. Further, we have to separate the gases. We will use, we will do the fractional distillation of a liquid air. And if there are miscible liquids, then like ethanol and water, we will do the fractional distillation. So basically, this separation, as we have seen, it depends upon the difference in the boiling points. If, for example, there are two liquids which have all similar boiling point, then we cannot separate those liquids with the fractional distillation. Because both have the same boiling point, so both will boil at the same time, so fractionation columns could not able to separate the vapors or the gaseous molecules of those liquids. So we'll do different, other than, fractional distillation, we go for other methods. Like sometimes for that, we can do chromatography. If these are the amino acids, then we will do chromatography. Okay. So this is the process of fractional distillation. Here we have discussed the purpose why we are doing fractional distillation. These notes are shared with you guys. You are aware in the group, right? Okay. Complete this quickly.
Sir,
Yes,
what is mean by the fractions of hydrocarbons?
fractions of hydrocarbon means different types of hydrocarbons like petrol, diesel, naphtha, kerosene oil, fuel oil. So these are different fractions.
Okay, sir.
Different kinds of fuels breaks it down.
Hmm?
Different kind of fuels.
Yes, in bracket you can write.
बढ़िया से जब गैस सेपरेट करने होंगे
Hmm.
तो गैस वापस दोबारा कंडेंस हो जाएगी.
But sometimes they are collected as a gas as well.
Okay.
But the actual thing is to separate, so they get separated. You still here? Is this clear? Yes, how much left, Rohit? Okay. Then, Rohit, then. Yes, how much is left? Okay. When we talk about the fractional distillation of crude oil, so fractional distillation of crude oil is basically not be done like this because that's what we do in labs. Okay, so the crude oil is always taken out from the underground, so it's in very large quantities. So it is instead of lab, it is then in a fractionating column, which is a very long and a huge tower. So what we will do, we will heat the first petroleum or the crude oil, and then transfer that heated petroleum in that fractionating column in that tower. So they start evaporating in that fractionating column. The ones with the have a smaller size. Okay, the other thing about that, the whole column is that at the top of the column it's cooler, and at the bottom it is very hot. So the molecules or the liquids which are in that crude oil with the smaller structures or with the smaller numbers have a low boiling point, and the one with the bigger structures have a high boiling point. So the one which are very lighter and are small in size will reaches to the top, and at the top of the fractionating column they condenses over there, and then they will be collected from there. So as their size bigger, they travel a smaller distance and then collected at different stages or different points from the whole fractionating column. So that's how the fractional distillation of crude oil can be done. So complete this, and then we will left with chromatography that we are going to do in our tomorrow's class. What?
नहीं पूरा बस
What was your grade in this time? Return it and- Yeah, question क्या है? Yeah, tuition से जब आपके एग्जाम शुरू हो गए थे, आपका मतलब in this call. So we will end the class over here. Okay. As you guys finish, you can leave.